All right, hello everyone. We are starting a new unit. Our new unit is on systems of equations. So, still building off of what you all previously have been working on with um, slope and slope intercept. But today we're going to kind of dive deeper into systems of equations. So, we're going to do a little bit of solving throughout the next couple of days. This unit we're gonna probably finish by the end of next week. So you'll be assessed by the end of next week. So you want to make sure that you are paying attention because things are going to get a little bit more complex and a little bit more challenging. Okay. So we are talking about systems of equations. We know what an equation is. And when we're talking about systems, we're saying what are the different ways to identify and graph an equation on a, or I'm sorry, yeah, graph an equation. So what you all are doing, you should have in front of you is a foldable. We're just gonna make a foldable today and do some vocabulary and quick notes. So you should have a piece of paper. All you're going to do is you're going to fold it over as such, and then you're going to take some scissors, and what we're going to do is we're only going to cut the top half. Now, here is what I'm going to tell you because I messed up on a practice one that I did before I made this video. Do not cut the dotted lines that you see on the front. Okay? If you cut the dotted lines that you see on the front, it will literally cut off the information that you need when you open it up. Okay? So you do not want to cut the lines that you see on the front. What you do want to cut is the lines that you see when you open it up. Okay? Cut the lines that you see when you open it up. So what I'm going to do is I'm just going to turn it around. Only cut the lines that I see when I open my flaps. Okay? So I've only cut those particular lines. And then I'm able to fold it over. Now you will see that it looks kind of weird, right? Like the lines aren't matching up with the cut. But that's okay because as long as we have the information that we need in the inside, you're all good to go. Okay. So take a few moments. If your teacher wants to pause the video to make sure everybody got this point, then we will keep it pushing. Okay. All right. So I'm gonna take a pause for anyone to do that. All right, so we're back. Hopefully you've had some opportunity to cut this out and make it look similar to what I've got here. All right, so we're going to talk about three different types of systems of equations. Three different types. You have what we call one solution, no solutions, or infinite solutions. Okay, one solution, no solution, infinite solutions. So let's first kind of start with one solution. Also, before we get started, you want to have two things, two different writing utensils that are in two different colors. So if you just have a pencil, that's fine. And then you want to have either a marker or something that is a different color. What I'm using right now are some erasable ink pens. So I'm going to be using purple and green today, but you can use whatever you want. I know that there's some markers somewhere in the classroom, probably in the back of the room. But you definitely want to have two different colors, and you'll see why when we start doing our graph. All right, so we're going to first talk about what does it mean to have one solution. One solution, okay? All right, so let's go ahead and open our flap. So it says here that the slopes are, we're going to fill in the blank here too, and I'm wondering if I can zoom in. I don't know if I can. I'm not sure if I can. Probably not. But it says that the slopes are different, okay? The slopes are different here. When you only have one solution, that means the slopes will be different. What that also means is that the y-intercepts, remember, anything that is graphed on the y-axis, the y-intercepts may or may not be the same. If you have a highlighter, you can highlight that. I'm going to also, it's also already underlined, but I want to make sure that you know that these y-intercepts might be the same, they might not be the same. So when you're looking at two equations, you might have a y-intercept here, you might have a y-intercept here, okay? So they can be anywhere on this y-axis. They could be the same. You might have both here, or you might have two here. When you graph the two equations and they only have one solution, we want to remember that the two lines will intersect. So what does it mean to intersect? What does it mean when we have two lines that are intersecting? That means that those lines at some point cross, right? They some point cross in the coordinate plane, and they have a point in the middle where they are intersecting. And so, like the flap talks about on the front, there's only how many solutions? There's only one point, X and Y, where they intersect. So there is only one solution. Okay, there's only one solution. All right, so let's look at our example. This is why I want you to have two different color pens or two different colors to use. So what we're going to first do is we're going to graph our two examples. Okay, so the first one is y is equal to negative 2x minus 3. We have practiced how to graph these equations, y'all. So hopefully you do not need a humongous tutorial again on identifying the y-intercept and the slope. So we're going to add and graph this equation, starting with the y-intercept, which is negative 3. So here's my origin. I'm going to find negative 3. Okay, so I'm going to put a point on negative 3. And then from there, I'm going to use my slope to determine the rest of my graph. So, for example, I just want to put some paper over it. So, if my slope is negative 2, that's really negative 2 over 1. So instead of going up 2, I'm going to go down 2, 1, 2, and over positive 1. I know I cannot go any further, so I'm going to go the opposite direction. So instead of going down 2, I'm going to go up 2. And instead of going to the right one, I'm going to go to the left one. And I'm going to keep that pattern. Up 2, over 1. And let's do one more. Up 2, over 1. All right, and then as always, we're going to connect our dots. Okay? All right, so that is our first graph. Now we're going to do our second graph. So our second graph is y is equal to 2x plus 1. 2x plus 1, starting with our y-intercept positive 1. And hopefully y'all can see that that's, make sure we denote that. So starting with positive 1, and then our slope is 2, so we're going to go up 2 over 1. So up 2 over 1. Up 2 over 1. And I can't go any further, so now I'm going to go in the opposite direction. Down 2 over 1. Down 2 over 1. And let's see if we can do one more. Down 2 over 1. All right, and then once again, we're going to connect our dots. Okay. All right, so we've got both of our graphs. And so remember, we are talking about when two equations only have one solution, right? Two equations that only have one solution. Remember, when you graph, it says the two lines will intersect. We are seeing that our two lines that are two equations that we graphed, they do intersect, right? So there's only one point, x and y, where they intersect. So there's only one solution. So what we're trying to figure out, well, what is the solution? Where is that one point that they intersect at? And so we see here that this is where both equations intersect. So what is the ordered pair? What is our solution for these two equations? -1 and -1. Okay? -1 and -1. So remember, when it's only one solution, the line has to intersect. Okay? So before we go to the next piece, we want to make sure that we identify that anytime that we are going to have one solution, it means that the graph must intersect. Super important for you to remember, okay? That graph, the two lines will be intersecting. All right, let's jump to no solution. So we talked about when it's one solution. Let's now talk about it when it's no solutions. So you don't have a solution. So when you don't have a solution, or when there are no solutions, what do we notice? That the slopes, you will notice that the slopes are the same. So the slopes are the same. You'll also know that the y-intercepts are different. So the slopes are the same, but the y-intercepts will be different. When you graph the two lines, the lines are going to be the opposite of what happens when you have one solution, which are parallel. So what does it mean for two things to be parallel? That means that the two lines don't what? They don't touch, right? So here to here, right? These two lines will never touch, right? They're parallel. There is blank point. Well, if it's no solution, is there any point? No, right? There's no point where they intersect, so there is no solution. And then, like it says here, I'm going to highlight this. There is no number that will make the equation true or equal. No number, because there's no solution, okay? All right, let's go ahead and graph these two examples here. We're going to do the same thing that we did before. Make sure you have your two colors. And then before we actually graph this, I do want to make a note because I know some of you all love Desmos with everything in your heart. That is great. However, remember, the standard and the concept that you need to know is that you have to be able to graph it by yourself. Desmos will graph it for you, which is awesome. But you have to know also how to graph each of these equations. Okay? You notice that when you were doing your quiz, you have to know how to graph the equation on your own. All right, so let's go ahead and look at the first one. I'm going to use the same colors that I did last time, purple and green. So the first one, we know that the slopes are going to be the same, which is what it said, right? The slopes are the same. Both slopes and both of these equations are 2. But the y-intercepts are different. We have -3 and we have +1. So let's first graph our first one, 2x minus 3. So I'm going to start at my y-intercept -3. And I'm going to go in the direction that they told me, that the slope told me. So if it's +2, you all know that that's really 2 over 1. So up 2 over 1, rise over run, up 2 over 1. Up 2 over 1. Up 2 over 1. I'm just going to stop at 4 points. Okay. And I'm going to lastly connect my dots. Okay. All right. So that one's done. Let's do the second graph. Once again, our slope is +1. So I'm going to put my point on +1. And I know that my slope is 2. So that's 2 over 1 again. So now I'm going to go up 1 over 1. Up 2 over 1. up 2 over 1. And I can't go any further, but I do want to include 4 points like I did for the first one. So instead, I'm going to go down 2 over 1. And so once again, if you look at my graph and my two lines that I have shown, they are two parallel lines, right? When you graph, the two lines are parallel, and that's exactly what I have here. Two lines that are parallel, which means they will not cross. They will not intersect. So do you have a solution? No, because there's no point where where these two lines are going to intersect. Okay, so no solution. Keyword we want to remember is that these two lines are going to be parallel. Parallel is what we're looking for. It's keyword. All right, and lastly, before we come to a stop, we're going to talk about infinite solutions. So what do we know about the word infinite? And my infinity sign is kind of bad, but what does it mean when we talk about the word infinite? Infinite means many, right? On and on and on, multiple solutions. So what is it? What will the graph look like then? So let's go ahead and flip open that last flap. So when we're talking about infinite solutions, the slopes are essentially what? The slopes are the same. Okay, so the slopes are the same. You also know that the y-intercepts are also the same. Okay, which also means that they're equal. So the slopes and the y-intercepts are both equal to each other. When graphed, there is only, here's the key thing, y'all. When graphed, there is only one line. Okay, you got two equations, you got one line. Since the equations are the same, because if they're the same, you're literally going to have the same lines, right? Like, think about it. You have two equations that are equal to each other. So that means when you put it in Desmos and when you graph it on your own, it's still creating the exact same line. They're just on top of each other, right? So there are infinite solutions because remember, on a coordinate plane, these arrows mean they keep going, right? So if you have a line that keeps going on and on and on, it can go all the way up, it can go all the way down, it can go all the way to the left or to the right. So there's infinite amount of solutions. And then we're going to highlight this key phrase here. Any number will make the equations true or equal. Any number that you use. Okay. All right, so let's do our same scenario. We've got two examples. One will be for purple and one for me will be green. Please make sure you are using different colors because I promise you will help you denote which is which, okay? All right. So we've got two examples. The first one is already in slope intercept form, which is great. So we're going to go ahead and graph that one first before we touch that second one. All right, so we're going to start with y equals 2x plus 1, which is what I think we just did on a previous one. Yeah. So that was our green graph on the previous when we were talking about no solutions. So we know that this is going to look exactly like what our green graph should look like. Okay, so we'll start at positive 1. And our slope is telling us to go up 2 over 1. Up 2 over 1. And let's go down 2. We're going to go the opposite because we're running out of room over there. Okay. And let's do, that might be enough. Let's just stop there. So then let's go ahead and draw our lines. Okay. So there's our graph. Now for the second part, their second graph that we had, it is not in slope intercept form. Okay. So here is what's your job. Now you're telling me, oh, well, Ms. Barr, I already know that that's going to be because it's already under the infinite solutions. But you have to turn this into slope interform because originally you might not know that this is that these two equations are going to have infinite solutions. So you've got to solve for y to make sure that it is the same exact equation as the previous one. Okay, and we know how to do that because we did that last week, right? So instead of and so we have a negative 2x. Instead, what we're going to do is we're going to bring this around over here. So instead of saying plus 2, we're going to say minus 2. Okay? I'm sorry. Instead of saying minus 2, we're going to say plus 2. My apologies. Plus 2x plus 2x. Okay? The 2x's will cancel. And now I'm left with what we want. Y equals 2x plus 1. Okay, so all we did is we added 2x on both sides so that we have a new equation in slope intersect form, which we know should be the exact thing as what we started off with. So we can quickly see that both of these are literally the same, right? 2x plus 1, 2x plus 1. So we're going to grab it the same way that we normally would. And I got to make my circle just a little bit bigger so that you can see. Starting at positive 1 up to over 1. Up to over 1. And then we're going to go the opposite direction down to over 1. Okay? So as you can see, once I draw my lines, that our two lines, our two equations have are on top of each other. So it has only created one line, which means we have, like we stated before, many solutions, infinite solutions. All right, so when we're talking about infinite solutions, we want to denote that we are referring to one line. You're not going to have two lines that intersect. You're going to have one line on top of each other. Or that's pretty much what it's going to look like, okay? All right, so that is pretty much it that we're going to do today. We're going to do a little bit of practice on quizzes. I'm going to have you all do a quizzes assignment. But I want to just reiterate what we just talked about. When it is one solution, that means that the two equations will intersect, and you will only have one point where they intersect at. Okay? When it is no solutions, that means your two lines are parallel. Your two equations will be paralleled, and they will never intersect. Okay? But they will have the same slope. Okay, so the rise over run will still be the same, up to over 1, up to over 1. And then lastly, when you have infinite solutions, you are looking for one single line, not two, and not parallel, not intersecting. You have one single line that the equations are on top of each other. Okay, so that means you will have infinite amount of solutions. Okay. Please let your teacher know if you have any questions. Like I stated, what you guys are going to work on now is just identifying and doing some practice on one solution, no solution, infinite solutions, okay? Hopefully this was helpful for you. I will upload this video into Google Classroom. Please let me know if you have any questions, and I hope you all have a great day.